Hi there. Let's review how we use a formula called the Pythagorean Theorem to solve for the missing side of a right-angled triangle. So I've got a nice right-angled triangle to practice on, and it looks just like this. And I'll get you to try one a little bit later. There's some interesting symbols on this triangle before I even start any math. I can tell it's a right-angled triangle by this red square in the corner. And that's important because the Pythagorean theorem only works on right-angled triangles. The other thing is the corners of the triangles have capital letters, and the sides have lowercase letters. And in this case, I'm being asked to solve for this lowercase a, or the length of this side. And it also turns out that this side is a very important side for a right-angled triangle. It's got a name. It's called a hypotenuse. So the length of a right-angled triangle, or the side of a right-angled triangle, that's opposite to this corner is called the hypotenuse. You can think of it as this corner of this little red square is facing this side, and that's the hypotenuse. And to find the length of a hypotenuse, we need to take the squares of the other two sides, and then we'll take the square root of that answer. So let me show you what I mean. The actual Pythagorean theorem looks like this. A squared is equal to b squared plus c squared. Or the square of the hypotenuse, this length here, is equal to the square of the other two sides. To solve for a, I'll need the values of the other two sides, which are given in the question. They're 8 and 6. So let's start filling in some values. A squared is equal to 8 squared plus 6 squared. In my next line, I'll take the square of both of these. So I'll say a squared is equal to 8 squared, which is 64, plus, what's 6 squared? 36. Okay, and now I can put both of these two numbers together. A squared is equal to 64 plus 36. Well, that's 100. So now we're getting near the end. To solve for a, since it's being squared, I need to do the opposite operation of squaring, which is the square root. So to solve for a, I will take the square root of the number on the right, which was 100. And the last thing I'll do, I need to find the square root of 100. Now, if you need to use your calculator to find the square root, that's okay. Let's go ahead and do that. And I'll show you how I would take the square root of 100. Type in 100, and then I have a square root button. Yours might look a little different on your calculator, but if you hunt for it, you should be able to find it. And I'll just hit that once, and I get an answer of 10. So in this case, the length of my unknown side, or a, is 10. And the other two sides are in centimeters, so I'll say a is 10 centimeters. There we go. We just used the Pythagorean theorem to solve for the missing side of a right-angled triangle. Now I'll present a practice triangle that you can try and solve. Here's your practice triangle. So using the same steps I showed you on the left, try and solve for the missing side. Go for that now. So hopefully you got an answer of 5 centimeters for the hypotenuse of this triangle. And we got that by first listing the Pythagorean theorem right here, and then solving for the unknown side, we need to find the values of b and c, which are 4 and 3. We squared those to get 16 and 9. Then we added 16 and 9 together to get 25. And finally, we take the square root of 25 to get 5 centimeters.